Hi guys, welcome back to the vlogs. Happy Valentine's Day.
Okay, let's talk about 9.1. Chapter 9 is going to be polygons. So we're going to talk about lots of different shapes of polygons. And then we're going to eventually bring them back into circles so that we can do some other stuff with them. But first we got to learn rules of polygons. Okay, so 9.1 focuses on parallelograms and their diagonals. Okay? Parallelograms, we have several different kinds. We have squares, we have rectangles, we have an over-compassing term, that's parallelogram. We have rhombus, we have trapezoid. Basically, parallelograms are quadrilaterals that have four sides. Okay? So they're quadrilaterals with four sides. We're going to take a look at a picture in a minute that shows you how these relate to each other, okay? So, we'll get there in a second. And then it'll be a little easier if you look that way, okay? So there are several things about polygons. Polygons are often named after their sides, okay? So we have a pentagon because it's 5 sides and penta stands for 5. We have a hexagon, which is 6 sides, a heptagon, which is 7, an octagon, which is 8. Okay? So you need to realize that polygons are named after their sides. Okay? Quadrilaterals have 4 sides. So use some common sense when we're doing stuff. When I say pentagon, you need to know that that means 5. This stuff should be kind of review from like 3rd grade. You should have learned these shapes in 3rd, 4th grade, you know? Okay? So we're going to take looks at all different types of polygons. Okay, these ones are ones we're going to focus on a lot. Trapezoids, parallelograms, rhombuses, rectangles, and squares. Because we're going to have rules for all of them, okay? A trapezoid, okay, has exactly one pair of parallel sides. So if I were you, I'd draw a little trapezoid in my notes, and then beside it, it would say exactly one pair of parallel sides, okay? So it's one pair of parallel sides, because we're going to need to be able to use these type of rules in proofs. Okay, so a trapezoid has one pair of parallel sides. A parallelogram is this green one right here. Okay, its opposite sides are parallel, and they are equal in length. Opposite sides are parallel and equal in length. Okay, opposite sides are parallel and equal in length. Parallelograms have opposite sides that are parallel and equal in length. Right here, the yellow one, the one that looks like a diamond type thing, is a rhombus. Okay, what? Use draw it slanted. So a rhombus is a parallelogram with 4 congruent sides. A rhombus has 4 congruent sides. So all 4 sides are congruent and equal, okay? A rectangle, okay, is a parallelogram with 4 right angles. So a rectangle is a parallelogram that has 4 right angles. Because if you have a parallelogram, it doesn't necessarily have to have 4 right angles, but when it does, it becomes a rectangle. Okay? So some of these can be 2 things. Like a rectangle, I can classify as rectangle, and I can classify as parallelogram. Okay? A square is a rhombus with 4 right angles and a rectangle with 4 congruent sides. So a square is a rectangle, but a rectangle is not a square. Okay? A square is a rhombus with 4 right angles, and it's also a rectangle with 4 congruent sides. I think my next picture might be a picture of all of these like inside of each other, so you can see what classifies as what, I believe. But I'll give you a second, a couple minutes here. Okay? We have to be able to define them and know what they are separately. It's also on page 407. This whole chart is in your book in case you need to copy it from there, okay? Or reference back to it. then I get this. Okay? Do you see how the over-encompassing term is quadrilateral? Because a quadrilateral simply means that they have 4 sides. All of these objects have 4 sides. Next, the next terminology is parallelogram. Okay, look. Quadrilateral encompasses a parallelogram, a rhombus, a square, a rectangle, and a trapezoid. Okay? But under the hedge of parallelogram, okay, trapezoid does not fall in that. Because a parallelogram has 4 sides that are parallel, right? Like opposite sides are parallel. On a trapezoid, only one set of opposite sides are parallel, okay? So trapezoid is a quadrilateral, but it's not a parallelogram, okay? So after I have a parallelogram, within a parallelogram I have rhombus, square, and rectangle. So a rhombus, a square, and a rectangle are parallelograms, okay? Then you have a rhombus and a rectangle. Stop there. They're just parallelograms. But a square is a quadrilateral, a parallelogram, a rhombus, and a rectangle. So a square is everything. Okay? A trapezoid is just a quadrilateral. A parallelogram is just a quadrilateral. A rhombus, a rectangle, a square are parallelograms and quadrilaterals. A square is a rhombus, rectangle, parallelogram, quadrilateral. So when you have to classify these, they're going to want all of those. So when you get to a square, you're going to say square, and then under it, you're also going to say rectangle, rhombus, parallelogram, quadrilateral. Get what I'm saying here? You're going to have to know that that works for all of them. Because here's why. We're going to give you rules that come with geometry, like theorems. And it's going to say, in a parallelogram, here's a theorem for it. Well, I've got to know that a square is a parallelogram, because that rule can apply to a square. Or it can apply to a rectangle, or it can apply to a rhombus, okay? So I gotta be able to recognize that. Okay, figures. All 4-sided figures are quadrilaterals. All trapezoids are quadrilaterals. All parallelograms are quadrilaterals. All rhombuses are parallelograms. Okay? All rectangles are parallelograms. All squares are parallelograms. All squares are rhombuses. All squares are rectangles. So then, we get the parallelogram opposite sides theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So if a quadrilateral is a parallelogram, and the only quadrilateral that's not a parallelogram is what? A trapezoid. So any other shape that's a parallelogram, okay, that's a 4-sided figure, should be a parallelogram. So if it's a parallelogram, opposite sides are congruent. AB is congruent to DC, BC is congruent to AD. This is important because we can do things like this. What happens when I go like this?
Triangle.
And if I know that this side and this side are congruent, and this side and this side are congruent, and this side shared, then I know that those 2 sections are congruent because all 3 sides using side, side, side. This is why we need these rules, because now we can start to create things and prove stuff and solve stuff easier. We're halfway done. We're going to get to some example. I think the next thing we do is an example, and then we're going to do some more theorems and more examples. And I think it's what I showed you. Okay. Prove that segment AB is congruent to CD and AD. Let me see if I can shift this a little bit so that you can see it. Okay, so it wants us to prove that AB is congruent to CD and AD is congruent to BC, given that ABCD is a parallelogram. Okay, so I would start with the given, right? Given ABCD is a parallelogram, because remember, that's how we start proofs. Statements, reasons, okay? Now, where do I go from there?
2 triangles.
Well, let's state stuff we know about parallelograms first. I can make two, you wanna make two triangles? So what do you wanna draw then, Korea?
A line between A and C.
Okay, you wanna draw a line between A and C. Okay, we're gonna pretend that goes to the corner, cause I ran out of board space. If I draw that line, okay, I basically have just created a line segment, right? Okay, so I'll draw AC line segment. Okay. It's a construction. From there, what do I need to do? What do you know about parallelograms? What's the definition of a parallelogram? Tell me.
Opposite sides parallel and equal, right?
Okay, opposite sides are parallel, right? So why don't we start with something like that? Like AB is parallel to
CD.
CD and AD is parallel to BC, okay? AB is parallel to DC and AD is parallel to BC. Definition of a parallelogram, right? Yeah. Sorry. I know I'm getting. Okay, parallelogram, yeah. Okay, so if they're parallel, I got that, right? Okay, opposite sides are parallel, which means I can draw these little fun little arrows on them, right?
That's fine.
Okay, so now I've got that label. Okay, what from there? I need you to think about rules of triangles.
Alternate.
Okay, what are you telling me? Be more specific. She's saying something about alternate something. What does that mean?
That DAC is the same as
Okay, DAC and AC, DAC,
Oh wait, that would be C.
BCA, okay, and DCA, is that what you're saying? No, BCA and DAC are congruent, why? Nope, not because the triangle things tell me. They're alternate interior angles. Because if they're parallel, then I have alternate interior angles happening. So, I can say angle DAC is congruent to angle BCA. And I can say, so this one here, right, and this one here. And I can say this angle here and this angle here, right? So I can say, and angle BAC is congruent to angle DCA, alternate interior angles. Right? Okay, now what can you say from there? Now what can we say? Do they share something? They share AC. I can say AC equals AC. Why? Or AC is congruent to AC. Why? Reflexive. Good. Reflexive. And then from there, I have angle, side, angle. Yes? So I can say that those triangles are congruent. I have to move this up. I'm sorry. We're going to lose the picture. Okay. So I can say triangle ACD is congruent to triangle BCA using angle, side, angle. Okay? Angle, side, angle. So then I can say that AB is congruent to CD and AD is congruent to BC because they are corresponding parts of congruent triangles are congruent.
So a definition of a congruent triangle.
Triangle, yep.
Okay.
Okay. So AB is congruent to, what was it, CD? Yep. And AD is congruent to BC. Definition of congruent triangles. Okay. Which allowed me to prove that those parallelograms and that those sides are congruent. Okay? That allows me to prove why that theorem works. Okay? So, get ready to buckle up and do some proofs. And I told you triangles aren't going away.
I unbuckled my seat like
They're never going away.
I'm getting off this out of this car.
Parallelograms are nice little four-sided figures which makes two triangles all the time. Yay, yay, yay. Even trapezoids make two triangles.
opens the door and leaves the car.
Okay.
Out.
So, then we get these next two rules. Parallel angles theorem. Okay? Parallel angles theorem says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So A and C are congruent, B and D are congruent if ABCD is a parallelogram. Okay? If a quadrilateral is a parallelogram, then its adjacent angles are supplementary. What's adjacent mean?
Next to each other.
Next to each other. So that means that B and A added together are 180. That means that A and D added together are 180. That means that D and C added together are 180. And that C and B added together are 180. Which makes sense because the opposite angles are congruent, right? So if I split them and make two triangles, both triangles have to add to be 180. So those angles have to be supplementary. Okay? So you have parallel angles theorem. One says if it's a parallelogram, then opposite angles are congruent. The other one says if it's a parallelogram, then the adjacent angles are supplementary. Okay. I think we have like 2 more examples and maybe one more theorem. Yes. Okay. Parallel angles theorem. If the shape is a parallelogram, opposite angles are congruent. Also, if it's a parallelogram, adjacent angles are supplementary. Okay? That means that we have this. Okay. It says prove angle A is congruent to angle C and angle B is congruent to angle D, given that ABCD is a parallelogram. Where are we going to start with? This is the proof. Let's go. Given. Statement. Reasons. My statement is A, B, C, D is a parallelogram. Okay, now what? You want to draw AC? That's probably a good starting point always. Okay. So draw AC. It's just a construction, line construction. Okay, what next? You want to go with definition of a parallelogram again? What do you want to do with that though? What does the definition of a parallelogram tell me?
Don't do that.
No, I'm saying, what is the definition of a parallelogram?
I thought you meant like, what do you want to do next after that, because that was wrong, like what she.
No, she's right, I just need to know why we're doing that.
Opposite side.
Because the opposite sides are what? Parallel. So I need to say that AD is parallel to CB, right? and that AB is parallel to CD, right? Definition of parallelogram. Okay, which means this again.
Yes. She's sort of protected.
Right? Okay, now what can I do from there?
Don't you do the same thing? Alternate?
Yeah, alternate interior. Do the same thing, alternate interior. So angle DAC is congruent to angle
It's the same.
BCA, right? And angle BAC is congruent to angle DCA. Yes. I had to see what I had written down. And that is alternate interior. Okay, now what do I do from there?
AC equals AC.
Yeah, I'm literally doing the same thing. AC is congruent to AC because it is reflexive, yeah. The easiest one, and I can't remember it. Reflexive. Then from there, we have to do what? State that the triangles are congruent using angle side angle again. So triangle DAC is congruent to triangle BCA. Angle side angle. Okay. Now we can prove that the angles are congruent. Why? Angle B is congruent to angle D, and angle A is congruent to angle C because definition of congruent triangles. Okay, so that proof is basically literally the same thing. Just the last step is different because I was proving angles instead of sides this time. Cool? Okay. Now, last theorem for today. Parallel diagonals theorem. If the quadrilateral is a parallelogram, then its diagonals bisect each other. Which means if they bisect each other, what happens when something bisects? Cuts it in half. Not perpendicular, bisects. Okay. So if ABCD is a parallelogram, then that means that this part here, AE, is going to be congruent to this part here, EC. And that means that DE is going to be congruent to EB, which now I have 4 triangles going on, and I can start to prove more things. Yay! I know you're thrilled by that, I can tell. I can tell by the excitement that is exuding from you. Okay, so if I have parallelogram, I can draw diagonals. The diagonals bisect each other, which means they cut each other up into 2 equal parts. Okay? And then we'll do one more example, and then we will be done. And you will have some homework over your nice long weekend. Okay. Let me know when you're ready. Okay, let's look at our last example. Okay, where do the parallelograms diagonals intersect? This time it's on a grid and they want to know where it intersects. So do me a favor and think this through. How can we figure out where they intersect? No, I want math behind it.
Just count it.
Nope, I want math behind it.
Distance formula.
Not the distance formula.
Oh, it's a good shot.
Let's talk to me about
The
what.
midpoint formula.
Yes, because the diagonals bisect each other, which means they cut them into
Halves, so the
Halves.
middle.
midpoint
Yeah,
formula.
because it's in the
Okay,
middle.
midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2, right? Okay, so now we have to just figure out what the points are, and then we can figure out where the midpoint is, where it bisects, yes? Okay, so let's do that. Let's see here, what are my points? This point right here, it doesn't matter, I can go with this point and this point, or I can go with this point and
I
this
think you
point.
should go with that point and that point.
This one and this one?
Yeah.
Okay. This is -2, -1, right? This is -9, -7, -5.5.
What?
Poor Kay.
Am I wrong?
No, you're not wrong, because it's in the middle of 5 and 6. Why would they do that? No. No.
It looks like it's -5, are you sure?
This is -5, that's -6.
I know.
That's going up.
You're going up.
I don't know, maybe.
It's like, it's -5.
You think it's -5?
Yeah, it's
Yeah.
It's like, yeah, it's like
So -9, -5.
5. Sit down.
Okay, so, -9 plus -2 over 2, right? And -5 plus -1 over 2, boom. -9 and -2 is -11, right? So I get -11 over 2. And then I get -5 and -1, which is -6 over 2. So what's 11 divided by 2? 5.5, right? -5.5 and -3. So when they wanna know where my intersection happens, you use the midpoint formula. Cool? That's what this whole section is about.
Come on, Bryson.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Bryson? Anything to add, Korea?
Hi.
Say hello.